Greetings and welcome, friends. Mr. Waddy and my algebruddies in the house. We're talking normal distribution. This is great. And we talked about how oftentimes when you collect a lot of data, you will have an average of that data, which is the mean, and then you will have a typical distribution of the data from that mean, where on average it's a certain number of standard deviations between or away from that mean. And so this was called a bell-shaped curve. It's a normal curve as so. And if I'm familiar with the typical percentages for the areas under this curve, you can actually then calculate the probability of those regions very easily just by comparing it to this chart. So if I want to figure out the area between, this is 3 standard deviations below the mean and 1 standard deviation below the mean, right? So here's my mean. That's my x bar. You can also call it the Greek letter mu. So that's 1 standard, 2 standard, 3 standard deviations. And I want to find the area between these two. It's a little bit trickier using this version, but this version's not bad at all, right? Let's use this guy right here. So if I want to find that, I would just simply add up the following, right? I would add 2.35% plus 13.5%. And what does that end up equaling? 15.85%. Questions on that one? It is possible to use this version as well. I would have ended up, yeah, I'd have to use the, I would have used the 99.7. I'd subtract the 68, so I would have done 3, right? And then I would have subtracted this. But then I have like twice as much as I want. Right, I would have had the left side and the right side, so what would I have done to get rid of that? Well, if I have this and this, I only want half of it, because this graph is symmetric about this mean here. So this is minus 68, and if I divide that result by 2, I should end up with the same thing. So that's another way to do that one. Let's take a look at some of these other ones. I think I've got 4 more problems to look at. All right. So the following says, right, normal distribution. It's got a mean of mu and a standard deviation of little sigma. Find the indicated probability for a randomly selected value of x from the distribution. So this p is referring to probability. Find the probability that x is bigger than or equal to the mean plus 2 standard deviations. So here's my mean, 1, 2 standard deviations. I would be looking for everything greater than this all the way out to infinity. Okay? Is what I'd be looking for. Ethan, you can close that. Thank you. So if I want everything beyond that, yeah, I think I would end up adding those two together. Do you guys agree? 2.35 plus 0.15, which is equal to 2.5%. Question? Oh, well, I'm referencing a chart, right? So that's the way I know it. So I'm shading the spot that I want, and then I'm matching it to the chart, and I'm realizing I want that amount plus that amount. So that's what you gotta become familiar with. How about this one? This is 3 standard deviations below the mean. So that's from here all the way up to the mean. Right, so this is the spot that I'm talking about. So I want all 3 of these little spots, all of those regions. And so that's going to be 2.35 plus 13.5 plus 34. Let's see if I can write these down. So this is 2.35 represents this space right here, plus, I already forgot, 13.5 plus 34. And what is that up to? 49.85%. Right? So the likelihood of it landing in that region is 49.85%. Right? Okay, so so far it's a little bit kind of like arbitrary. We're just like talking about mu's and sigmas, some Greek letters. So these next problems is where we actually start applying it a little bit more. All right, here we go. Ah! I done jumped it. There we go. So guys, so for this next problem, let's label what we got. So my starting value is going to be the mean, which the mean is 33, so that's going to be right here. And the standard deviation is 4. So I'm going to count by 4s when I label this. So 33 plus 4, right, is going to be 37. 37 plus 4 is 41. 41 plus 4 is 45. And 33 minus 4 is 29. 29 minus 4 is 25. And this would be 21. Let's label the other one here the same because it's talking about the same set of data. So now this would be when I actually have, right, I've been given a number, or I've calculated a standard deviation and a mean for a set of data. And then what I'm going to do is try to figure out what percent is going to land in a particular range. So it says, what's the probability it lands between 33 and 45? So that's this space right here. It doesn't go off forever. It cuts off. Right? And so that's going to be very similar to the one we had a moment ago. So that's going to be what? 34% plus, what's that? 13.5%. Plus, and then this is 2.35%. And what's that equal to? 49.85%. Right? And so now, instead of just having this random percent, I know that it applies to, right, the number of whatever this data is. The likelihood of any data point being between 33 and 45 is almost 50%. Okay? That's what that would represent. So that's what we end up having here. Let's see. What do you think these numbers could represent? I don't know. Maybe ages of people at a particular event. So you could say that like half of the people there almost were between 33 and 45. What about if I said at most 37? So that would be a line at 37. And at most, does that mean I want the ones less than it or above it? That means if it's at most, that means 37 is the biggest. Yeah, so I'm going to want everything below all the way out to, right, infinity, all the way to the negative infinities there. Although if it's talking about age, I suppose it would have to end at 0-year-olds. Or at least up to like negative 9-month-year-olds. So, something like that. So if I want to calculate the area of all of this, here's actually, watch, this is how I'm going to do it. I'm going to count that the same as half plus this. So this is 50%, right? Everything to the left of the mean. Do you guys agree? And everything in here is what percent? What's that, 34%? So this is going to be 84% of my data is 37 or less. Okay? So that's how you set these up. Thanks for watching, Internet friends.